The most dangerous things in nature are not the ones you can see. They are the ones that were already there before you started looking. Camouflage is one of the oldest survival strategies on Earth, and over hundreds of millions of years of evolutionary pressure, nature has taken it to levels that are genuinely difficult to believe until you see them. We are going to show you those levels today, from the basics to the extraordinary. Welcome to the ultimate levels of camouflage in nature. The snow leopard is where most people's understanding of camouflage begins, and for good reason. Its coat is rock gray, matching the high-altitude terrain of Central Asia almost exactly. But the color is only part of it. The spots are what scientists call disruptive coloration, a pattern designed to break up the outline of the animal's body so that the brain of a prey animal or a predator cannot resolve it into a recognizable shape. The spots are not just decoration. They protect the animal from the visual systems of predators that look for edges, for silhouettes, and for the coherent form of an animal. A snow leopard can be a short distance away in open terrain and still not register as an animal until it moves. That is a documented consequence of how disruptive coloration works on the visual system, and it is only the beginning. The snow leopard blends into a background. The leafy sea dragon, however, goes further than that. It does not merely match its environment, it impersonates a specific object within it. The leafy sea dragon is a fish found in the waters off southern Australia. Its body is covered in leaf-shaped appendages that drift and sway exactly as seaweed does in a current. It also moves at the pace of floating vegetation, not at the pace of a swimming animal. The result is not an animal hiding in seaweed. It is an animal that, to every visual and behavioral signal available to a predator, simply is seaweed. This is called mimicry, the imitation not of a background but of a specific, uninteresting object. The strategy works because predators do not waste energy investigating things that are not food, meaning the leafy sea dragon has made itself, at a neurological level, not worth noticing. The potu is a bird found across Central and South America. During the day, it does not hide. It sits in plain sight, on an exposed branch or broken tree stump, and simply does not move. But the stillness is only part of it. The potu aligns its body along the vertical axis of the branch, tilts its head upward at the precise angle of broken wood, and holds that posture for hours. Its feather patterns match dead bark. Its eyes close to narrow slits that still allow it to monitor movement without revealing the round shape of an open eye. This is cryptic behavior, and it is a level of camouflage that goes beyond appearance entirely. The potu is not just shaped like a branch, it has learned to be a branch, in the behavioral sense that matters to a predator scanning for movement. Most camouflage fails the moment the animal moves. The potu removes the movement altogether. If the potu represents the behavioral peak of camouflage, the leaf-tailed gecko of Madagascar represents the anatomical one. Its body replicates a dead leaf, down to the veining, the irregular edges, and the brown discoloration of decay. Its tail is shaped and colored like a leaf that has been partially eaten, with what appear to be bite marks along the margin. Its skin texture matches tree bark, and it flattens its body completely against the surface it rests on, eliminating the shadow a three-dimensional object would cast, and that would immediately give it away. There is no single feature here that creates the illusion. It is rather the combination of color, texture, shape, edge detail, posture, and shadow elimination working together that produces something closer to a complete sensory deception than anything else in the animal kingdom. The level of precision involved is, by any measure, extraordinary. Every example so far involves an animal that evolved its camouflage over millions of generations. The decorator crab, however, takes a different approach entirely. It builds its own. Decorator crabs actively collect material from their environment, including seaweed, sponges, anemones, and sediment, and attach it to specialized hooked hairs on their shell. Also, as they move into different environments, they redecorate. A crab moving from a sandy patch to a rocky reef will remove the sand-colored material and replace it with material that matches the reef. This is called self-decoration, and it represents something genuinely unusual. an animal that has not evolved a fixed camouflage but instead evolved the cognitive and behavioral capacity to construct an adaptive one. Evolution did not give it a disguise, it gave it the ability to make one. That distinction matters. Every level of camouflage discussed so far is defensive. The orchid mantis, however, uses it offensively. The orchid mantis is an insect found in the rainforests of Southeast Asia. Its body replicates the appearance of a flower with a precision that goes beyond what simple concealment would require. The coloration, the petal-shaped limbs, the way it positions itself among actual vegetation. All of it is calibrated not to hide from predators, but to attract prey. Pollinating insects navigate by flower recognition, and the orchid mantis exploits that system directly, presenting itself as a food source to the very animals it intends to eat. Studies published in the American Naturalist have shown that in field conditions, the orchid mantis attracts roughly 30% more pollinating insects than actual flowers in the same area. So it is not just mimicking a flower, it is outperforming one. This is aggressive mimicry, and it represents a fundamental shift in how we think about camouflage. It is not only a survival tool, it is also, in the right circumstances, a hunting strategy. Everything discussed in this video is a fixed strategy. The snow leopard has one camouflage, the leaf gecko has one, the orchid mantis has one. They are extraordinary, but they are singular. The mimic octopus, however, has all of them, and it chooses between them in real time. The mimic octopus found in the Indo-Pacific can change both color and body shape almost instantly. It can flatten itself to replicate a flounder, trail its arms to mimic a lionfish, or coil into a spiral to imitate a banded sea snake. It does not cycle through these randomly. Research has shown that it selects its impersonation based on the specific predator it is responding to, choosing the disguise most likely to deter that particular threat. What makes this possible is an unusual nervous system. Roughly 2/3 of the octopus's neurons are distributed through its arms rather than centralized in its brain, meaning each arm can process information and act semi-independently. The result is an animal capable of making complex, context-sensitive camouflage decisions across its entire body simultaneously in a fraction of a second. It is not simply the best camouflage artist in nature, it is the only one that treats camouflage as a dynamic intelligence strategy rather than a fixed physical trait. The animals in this video are not hiding because they are weak. They are hiding because nature is fundamentally a resource problem, and the most effective survival strategies are the ones that cost the least energy while returning the most safety, the most food, or both. Camouflage at every level, from the snow leopard's disruptive spots to the mimic octopus's real-time impersonations, is a solution to the same fundamental question: how do I remain in this environment without being removed from it? The answers vary enormously. The logic behind them, however, does not. Every species on this planet is dealing with that question continuously, and most of them are doing it in ways we cannot see. Which is, of course, exactly the point. To close, what we hope this teaches you is simple. The natural world is not just more complex than it appears. In many cases, it is specifically designed to prevent you from seeing it clearly at all. The ones that survived long enough to be here are the ones that got very good at that. And the mimic octopus, for what it is worth, is better at it than anything else that has ever lived.